Now, I don't know how confident you are about remembering things like the players and the coach. I bet a few years ago you would have known that without any problem whatsoever, and now you can't come up with it when you need it. So I think that kind of memory disturbance is not part of normal aging. It is not part of aging. I think it is a memory decline caused by disease. And the disease that most often affects us as we get older in this day and age, I would say that almost always that's Alzheimer's disease. And it should be treated because now there are drugs that help stabilize things where they are. Now, there aren't any drugs that will cure it. We don't have those certainly now. But compared to where we were even 5 years ago, there's been a tremendous amount of advance, and we hope that that pace will continue.
I sure do.
I do too. For my sake, anyway. And everybody, and other people that's going to follow me.
Right.
Oh, it's just hell when you can't remember things.
Here, so we're looking at these guys there.
See, and then this is a really diffuse deposit here. And
here's a good diffuse one.
yeah, this is actually representative of almost all three stages.
In labs all across the world, neuroscientists are closing in on the mystery that has baffled them for nearly a century. What causes Alzheimer's disease? Alzheimer's disease ravages the brain, killing billions of neurons, leaving in its wake dark, twisted filaments called tangles, and large, sticky masses called plaques. For decades, scientists had no idea where they came from.
It took so long to figure out the beginnings of Alzheimer's disease because the brain scientists who understood what Alzheimer's looked like under the microscope didn't think that these plaques and tangles were going to turn out to be the key to the disease. They thought they were tombstones of the process.
But in the 1980s, scientists took advantage of new technologies to look more closely. They began to suspect that tangles and plaques were more than just tombstones. They were killers. Neurons depend for their survival on long chains of molecules arrayed like railroad tracks that transport nourishment across the cell. What keeps the tracks stable are short strips of protein called tau that work like railroad ties. In Alzheimer's disease, the tau mysteriously starts to curl and tangle, causing the strands of molecules to separate and collapse.
These things become twisted, and they just don't transport very well. You know, it's like somebody took the train track and went, yeah. You know, try and get a train to run along that, it just can't, it falls off.
If the material can't get where it needs to be, the cell is really going to collapse and eventually die. Looking at a cell late in the course of Alzheimer's disease, you see a cell that's literally choked with tangles of tau. Now, tangle formation is a long, slow process. That may be a very good thing, because if we can interfere with tangle formation early in the disease, what we may be able to do is prevent the progression of the disease.
Neuroscientist Peter Davies thinks he may have found one of the triggers that causes tangles to form, a protein inside the neuron called PIN1.
It binds to tau and bends tau, actually changes the shape of tau. What we would like to do is to test the idea that if we block the action of PIN1 on tau, we'll actually stop the tau becoming abnormal and becoming tangled tau.
Davies has begun work developing a drug to stop PIN1. But while he and others take aim at tangles, another group of scientists is targeting plaques. In the spaces between neurons drift thousands of molecules of protein. In an Alzheimer's brain, Some of them are suspicious protein fragments called beta amyloid. Sticky and resilient, bits of beta amyloid clump together to form an expanding mass called a plaque, which attaches itself like a barnacle to the outside of the neuron. Sensing a hostile invader, the brain's defensive cells fight back, releasing powerful chemicals. But the counterattack backfires. The chemicals set off a series of reactions that slowly destroy the neuron.